Today, we are going to see about traveling salesman problem using approximation algorithm. So, what is traveling salesman problem? The solution is the salesman want to visit all the locations just once and return to the original location. Let us explore it with an example. Now here we have 5 locations: warehouse, gym, home, office, shop, and these locations are represented as an undirected graph with corresponding weights in kilometer. So, let us find the shortest path from the given locations. For finding the shortest path using approximation algorithm, we need to follow few steps. 1. Starting with source vertices. 2. Finding minimum spanning tree for the graph using Kruskal or Prim's algorithm. 3. Pre-order walk of MST. 4. Corresponding Hamiltonian cycle. 5. Total cost. Now let us consider warehouse as source and construct a minimum spanning tree. Before going into the traveling salesman problem, let us see what is minimum spanning tree. MST is defined as connecting all the vertices together without forming any cycles with the minimum edge weights. There are mainly 2 algorithms, Prim's algorithm and Kruskal algorithm. Here we are using Kruskal algorithm. In Kruskal algorithm, we initially arrange the edges in ascending order based on their weights. And then we accept or reject those edges based on the conditions of the minimum spanning tree. Here we have constructed a minimum spanning tree using Kruskal algorithm. The minimum spanning tree using Kruskal algorithm is shown here. Next, pre-order walk of the minimum spanning tree is constructed. After this, we need to find the corresponding Hamiltonian cycle. First, the salesman go to gym from warehouse. The cost for visiting is 1 kilometer. Next, from gym the salesman moves to the home location. Now the cost for visiting home from gym is 4 and total cost is 5 km. Revisiting or returning to previous locations are not allowed in traveling salesman problem. Similarly, going back to original location, that is, warehouse, is not allowed. Next, from home he visits office. And the cost for visiting is 2 km, which is added to 5 km. Now cost is equal to 7 km. From office the salesman moves to the shop. The cost will change to 10 km as the distance between office and shop is 3 km. Finally, the salesman come back to the original location, warehouse, with the cost of 5 km. Thus the total cost for visiting all locations and returning back is 15 km. And the shortest path is shown here with minimum cost. Some of the real-time applications of traveling salesman problem are logistics, delivery, network routing. Thank you for watching.